Welcome to another introductory lecture about R. Today we'll introduce some basic data frame manipulations that get used in just about every single data analysis project that I do in R. The package dplyr provides a set of convenient and consistent functions that handle most basic common data frame manipulations and are designed to be chained together to create custom workflows. The way that we're going to chain these together is using this pipe command, this % greater than %, and I'm going to pronounce that pipe. The pipe command allows you to create very readable code. The idea is that the pipe command will translate this A pipe f of b into this expression f of ab. Basically, this A gets stuffed in as the very first argument into the function here. So this turns into f of a and b. Now, the idea is that reading code that looks like this, that is f of x, and then on the output of that do g, and then on the output of that do h. This sort of code is the code that only a mathematician would actually enjoy. Instead, what we're going to do is we're going to use this pipe command, and this pipe allows us to write x, take x, stuff it into the function f. The output of whatever that function gives, go and stuff that into the function g, and then the output of function g, stuff that into h. And so as I read this code, I take x, then I do f, and then I do g, and then I do h. And this is very readable as opposed to this sort of mathematician's code. So down here in this example, I'm going to take a vector that is this collection -1, 0, 1, and I'm going to first take the absolute value and then I'm going to sum it. So I can first take the absolute value and then I get this -1, 0, 1, and then I'm going to sum the result and I get 2. So this is actually relatively easy. Take a vector, take the absolute value, sum it. If I were to write this in sort of a standard nested way, I would write it like this, where I have to read from the inside out. Take this vector, apply the absolute value, and then apply the sum. Between the two of these, this first set of code is much easier to read, and therefore to not make mistakes when writing, or to catch your mistakes when you're looking for your mistakes. So I really like this pipe operator. So to reiterate, if I write A pipe f of b, it turns into f of ab. B pipe f of a, and then this dot gives me a way of taking whatever is on the left-hand side of this pipe operator and stuffing it wherever I want. So this will turn into f of ab. And this is sort of my usual way of using it, is x, then apply f to that, and then apply g to whatever the result is. Now, the beauty of this pipe command really comes in when you've got a suite of functions that are all designed to work together, and their first argument is the same as their output argument. So in dplyr, in the package dplyr, every function takes a data frame as their first argument, and the result of that manipulation is a data frame. And by using this pipe command, I can now just pipe operations together one right after another and make very readable code. We're now going to talk about the basic actions in data wrangling. I want to be able to take a data frame and add rows to it, or maybe combine two data frames to end up with one large data frame. I want to be able to take a data frame and take a subset. Perhaps I want to be able to select particular columns, or maybe I want to select particular rows, and that's going to be called a filter. Or in that process of taking particular rows, maybe I want to, instead of the next thing that I want to be able to do is take a data frame and take subsets. Now I could think about this subsetting as taking individual columns, and that's going to be called the select operation, which is selecting particular columns. Or maybe I'm going to want to do is create or grab particular rows, and this is going to be called a filter. And the filter command is going to select particular rows based off of some sort of logical comparison. The other way that I could select rows is by just selecting particular row numbers. So grab me the first through 10th rows, something like that. That's going to be a slice. So those two types of things are going to be my subsetting operations. The next thing that I want to be able to do is to take a data frame and rearrange the rows. This is going to be done by the arrange command. Next, I want to be able to take a data frame and create new columns, or take an old column and modify it in some way. This command is going to be called mutate. I want to be able to take a data frame and collapse it from maybe 100 rows to maybe 10 rows. This is going to be this process of taking many rows and collapsing it to one summary row is going to be called summarize. Now, each of these operations is going to be done by a particular function within the dplyr package. Within the dplyr package, once I've specified the data frame as the first argument to the function, I can then subsequently use column names without quotation marks and without any sort of $sign notation. It's very convenient. All right, so to begin with, let's create a couple of data sets. We've got a couple of doctors that are the mentors and a couple of doctors that are the residents. Now, the first thing that I might want to be able to do is I might want to be able to add a new row to this. So I'm going to take my residence data set here and I'm going to print it out. And we see that I've got two rows, Dr. Dorian and Dr. Turk, and I'm going to add a row to this. Now, the function that I'm going to use to do this is going to be this add row command. And I'm going to add Dr. Reed, and she has an exam score 1 and an exam score 2 as I've got down here. Now notice that I haven't included her gender or her final exam score, and anything that I don't include in this function gets filled in with an NA, and NA stands for not available. Notice in this command I've created a new data set and I've actually printed it out. I haven't assigned this newly created data set to anywhere. So let's go ahead and look at what residence still is. And right now residence is still just the 2-row thing. When I added this row, I haven't saved the result back onto my residence data frame. So in order to actually save Dr. Reed, we need to take my 2-row data set, add a row, and this result is going to be saved back on top of the residence data frame. So basically I'm overwriting the 2-row data frame with this new version, which is 3 rows. So I'm going to go ahead and run this. And now I've got 3 rows and Dr. Reed has both her gender and her final exam score. Now I've got these 2 data frames. I've got my mentors and I've got my residents, and now I want to combine those 2 things. So I'm going to use this command called bind rows, which will take 2 data frames and squish them together. They'll stack them one on top of each other. And the mentors is going to be the first group, and then the residents is going to be the second. And so as a result, the Dr. Cox and Dr. Kelso are going to be the first 2, and then my residents will be down below. The next thing that I want to be able to do is I want to be able to select particular columns. Now there's many ways that I can do this using the select command. So I'm going to take my data set and I'm going to pass it into the select command, and I want to select columns exam 1 and exam 2. Now in dplyr is very clever, and I don't have to specify my column names in quotes, and I can just write my column names with them being bare. And this is a feature of dplyr, but does not exist in base R. So in this case, I'm going to take my data set and I'm going to grab columns exam 1 and exam 2. there are other things that I can do. This colon operator we've already talked about. That was a useful operator for being able to create, say, a vector of numbers 1 through 10. So 1 colon 10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. dplyr overwrites that colon operator and allows it to work on column names. So what I'm going to do is I'm going to grab exam 1, or the columns, exam 1 through the final exam column. So this gives me exam 1, exam 2, and the final exam. Negative indexing also works. So this will give me everything except exam 1. And as you would expect, I could do everything by just specifying the column number. So this will give me columns 1 and 2. Generally, I don't ever have to do this. I prefer doing it by name, but this can occasionally be useful where I grab both the first and second column. Now there's a few other tricks that select has, and select interacts with these functions starts with, ends with, and contains, and this does some very basic pattern matching, and I might want to grab all of the columns that starts with the letters exam. So this would grab exam 1 and 2. So this is very, very basic pattern matching, and select works just fine with this. If I give it two different patterns, what'll happen is it'll combine those two using an OR statement. So this will give me all the columns that starts with exams or starts with the letter F. And so this will give me exam 1, exam 2, and the final exam. Instead of selecting columns, maybe I want to be able to select rows. So what I'm going to do is I'm going to use this filter command, and this filter command is going to take my gradebook, and I'm going to grab the rows where the final exam is greater than a 90. So I'm going to grab this first, fourth, and fifth row. So that gives me Dr. Cox, Dr. Turk, and Dr. Reed. I can have multiple statements here, but here it gets combined as an AND statement. So this will say, give me from the grades data set, give me all the rows where exam 2 is greater than a 90 and the final exam is greater than a 90. So this will give me, so this will get rid of Dr. Turk. And I'm just left with Dr. Cox and Dr. Reed. Now, I could explicitly combine these two statements using an AND condition. An AND is with an ampersand. The OR condition is actually just a single vertical bar. So explicitly, we could have this AND. If I go ahead and do this as an OR, this case where exam 2 is greater than 90 or the final exam is greater than 90. So either of those two being greater than 90 is sufficient. The final thing that I might want to be able to do for selecting particular rows is I might want to be able to select particular rows by row number. So this command is called slice, and this will just give me rows 1 and rows 2. So this is my two mentors. The next thing that I want to be able to do with my data set is I need to be able to arrange the data set in, say, alphabetical order, or I need to arrange it by particular columns. So we're going to use the arrange function to do this. And to start with, we're going to start by default going by last name. And so this is going to order it by default using alphabetical order, Dr. Cox, Dorian, Kelso, Reed, Turk. I can pick which column I want, so let's take our final exam, and I'm going to order it by final. Now by default, it'll start with the smallest and go to the largest, but oftentimes I want to go biggest to smallest. And so I could switch the order just by using this descending function, and that'll switch the order from, say, smallest to largest to reverse it and be biggest to little, or if it's alphabetical, instead of A to Z, it would be Z to A. So I can use descending to get Dr. Reed being first. Now this arrange command can be used on multiple columns, where first what we're going to do is we're going to arrange our data set by gender first. And so this will first split it into females and then males. And then within those males and female groups, we'll sort them by exam 2, again in descending order. So now we have Dr. Reed as being the first female, and then the rest of the doctors which are male, and we're ordering this by exam number 2. The next thing that I want to be able to do is I want to be able to create a new column. The way that we're going to do this is we're going to use a function called mutate. So the way that we're going to do this is we're going to use this mutate command with a new column equals some function of either old columns or constants or whatever you want, but it's new column equals old column. So we're going to take our old data set grades and we're going to calculate an average, which is going to take exam 1, 2, and the final and divide by 3. So we'll take new column is equal to some function of the old columns. Now I can do multiple transformations in this same mutate command. So I put a comma and I'm going to put my next command, which is going to take my average score, and we're going to use this cut command. Now we haven't talked about cut, but it allows us to take a numeric variable and transform it into a categorical variable. We'll talk about this later, but this is a nice trick for taking my average and turning it into a letter grade. So let's go ahead and calculate these 2 new columns, average and grade. Now, if I need to update a particular column that is already there, one of my favorite tricks is to use a command that is called if else. And what this does is it checks some condition and then you give it 2 values, a true value and a false value. I'm going to take my grades data set and I'm going to update my final exam. And I'm going to look at Dr. Reed and say, oh, she didn't get 100, she got a 98. So what I want to do is I want to update this final exam column. So that's what this is going to do. We're going to take my grades data set and I'm going to mutate and I'm going to say final equals something. So what this is going to do is it's going to overwrite my column final, and what it's going to do is it's going to update it to the output of this if else command. And what's going to happen is it's going to go through this last name column, and whenever there is an is equal, so this double comparison right here, that is going to check for an equality. So this is going to say wherever you have a last name that is equal to Reed, change the final exam score to be 98. For every doctor whose last name is not Reed, the score is going to be whatever was already in the final exam column. So what this does is this allows me to update my final column. I can update a whole bunch of things actually. So it doesn't have to be just what was already there. Now, for example, my gender column, I've got M's and F's. Perhaps I want to change those. Instead of being M's and F's, maybe I want them males and females. So what I'm going to do is I'm going to update my gender column and I'm going to check and see, hey, if gender was equal to an M, so if is equal to M, replace it with a male. Otherwise, replace it with female. So now we've got this updated where all of my M's have gone to male and all my F's have gone to female. Now this works really well when I have 2 categories, but if I have 3 or more categories, if else or nesting those if else commands is really kind of a pain. So instead what we'll do is we'll use this function that is called case when. And the way that this is going to work is you're going to have a logical expression. So that's going to be the gender equal M or gender equals F or whatever, and then the output of that. So this is actually a very convenient case. So I'm going to make a quick little data set here where I've got 6 different people, and we've got Barack and Michelle, George and Laura, and then Bernie and Deborah, and these are well-known political figures. Now, if I want to make some sort of modification to this data frame, for example, I want to convert my ones to be males and my zeros to be female, I could use this gender equals if else. If gender is equal to, and remember this is a double equals, is equal to 0, zeros are female, ones are male. But party, because Bernie Sanders is most accurately described as an independent, I want to have this case when statement. So this is going to check for a quick thing. If party is equal to 1, label them a Democrat. If their party is equal to 2, label them a Republican. If their party is equal to 3, label them as an independent. Now, oftentimes my case statements have a last final test, and this will always evaluate to true. So if my party value is anything other than 1, 2, or 3, then we're going to use this option for none stated. So we're going to go ahead and update this data frame to be, instead of my zeros and ones, we're going to have males, females, Democratic, Republican, and independents. The last final basic thing that I need to be able to do is I need to be able to take a data frame with many rows, and I need to be able to collapse it down to a single row. So this is going to take a data frame and summarize the data frame, or summarize all the rows into just one row. So what I could do is I could take my grades data set, and maybe what I want to do is I want to take exam 1 and I want to calculate what is the average of exam 1. So I can calculate the mean.e1. So this is going to calculate the mean of exam 1, and this is going to be just equal to some function that I calculate. So I'm going to take my exam 1 column and I'm going to calculate the mean, and I'm going to assign that to M1. Cool, so now we're left with a data frame again, but it's a data frame with just one row, and it just has just one column. Now I could have calculated 2 or more summary statistics. So here I'm going to summarize my data frame by calculating both the mean of exam 1 as well as the standard deviation using the SD command of exam 1. So now I'll end up with 2 columns. So now I've got a mean of exam 1 and a standard deviation of exam 1. And again, this is still a data frame. A very powerful trick is going to be something that I'm going to refer to as split, apply, combine. And I want to take a data frame where I've got one variable that is my grouping variable. And what I'd like to do is I'd like to apply some function or some summarization or some action to each group separately. So what I'm going to do is I'm first going to take my data frame and I'm going to split my data frame up into what I want to think of as 3 sub data frames, where these are individual objects. Now to each one of these data frames I want to apply some action. It might be a summarization, it could be a mutation, it could be whatever I want. But I'm going to apply some action individually to each of these data frames. And then once I have these results calculated, I'm going to combine the results of these individual sub-data frames back into a single data frame that is going to be the end result of my calculation. To begin with, let's talk about a simple data set called warp breaks, which talks about a couple of different types of wool, and it has the number of breaks as the wool is being spun from wool into a type of string or yarn. Now we've got 2 different factors of wool, and as it's being spun together, it's got 3 different tensions, and it's got a little graph that's going to look like this. And you can see that for wool type A, we've got a large number of breaks at low versus medium and high tension, whereas wool type B, it's a little bit different. And I want to talk about how do I take this data set and summarize it. All right, so here's what we're going to do is we're going to introduce a brand new function that's called group by. And what that is going to do is every time I do something subsequent to calling this group by function, it'll be done by subgroup of my data set. So what I'm going to do is I'm going to take my big data set and I'm going to group it by my wool and tension combinations. And so this is going to give me 6 different combinations of wool type and tension level. And then when I call my summarize function, it will do it by subgroup. So what I'm going to do is I'm going to use this summarize function and this in function, which says just count the number of rows. And what this will do is for each wool and tension type, it'll give me the number of observations in that group. So this is going to be very convenient, where for each wool and tension type, so there's 6 of those, there are 9 observations in each one of my groups. Now I can do other calculations as well. Remember, summarize was very smart. I could calculate whatever summary statistics that I wanted from a data set. So in particular, I could calculate the mean in my breaks and I could calculate the standard deviation. But when I do it after a group by, it'll grab the mean and standard deviation for each group. And so now I've got my sample statistics for each group. Now, this is really convenient because I don't have to specify that there are 2 different levels of wool. I don't have to specify that there are 3 different tension levels. If there are 6 different types of wools and 20 different tension levels, this same code will calculate one set of summary statistics for each combination. This is extremely powerful, and this is very, very easy for us to do, and it doesn't require me, my programmer, to actually know the individual levels. The calculations that I could calculate for my whatever I want doesn't have to be a summarize function. It could still be a mutate function. So for example, I could take my data set and for each wool and tension type, I could calculate the mean of that group and then calculate the difference between what I've observed and what I calculate for that group mean. And so now instead of doing a summarize, I'm going to do a mutate, but this group by still continues to work. And so this is going to give me my residual observations for every observation in my data set, assuming I was going to do some sort of ANOVA analysis. In the next episode, we're going to start talking about some basic statistical modeling and how to do that within R very simply, as well as the basic ways to interact with those models. Stay tuned for the next one and have a good week.